The atmosphere extends upward from the Earth's surface for many miles. Near the surface, the air is relatively warm from contact with the Earth. In the United States, the temperature averages about 59 degrees Fahrenheit year-round. For every 1,000 feet of altitude, the temperature decreases by about 3.5 degrees Fahrenheit. At 35,000 feet above the Earth, the air temperature is approximately 67 degrees Fahrenheit below zero. For flight purposes, the atmosphere is divided into two layers. The upper layer, where the temperature remains practically constant, is the stratosphere. The lower layer, where the temperature changes, is known as the troposphere. This is where all the weather occurs. The atmosphere is composed of 78% nitrogen, 21% oxygen, and 1% other gases. The heavier elements, such as oxygen, settle to the surface of the Earth, while the lighter elements float to the higher altitudes. Obviously, a body of air as deep as the atmosphere has tremendous weight. The approximate pressure on the human body at sea level is 15 pounds per square inch, or about 20 tons on the average person. As altitude is gained, the air becomes thinner. Therefore, there is less pressure. At 10,000 feet, the average person's reactions are affected. At 18,000 feet, with only half the atmospheric pressure found at sea level, the oxygen intake would be half of the normal amount, and unconsciousness could result. Human body reactions would definitely be below normal. The actual pressure at a given place and time depends upon several factors: altitude, temperature, and density of the air. When atmospheric pressure is measured, it is known as barometric pressure. The most common measurement is inches of mercury. It can also be measured in pounds per square inch, as stated earlier, or millibars. The standard at which barometric pressure is compared to is known as the standard day. It is based on a temperature of 59 degrees Fahrenheit at sea level. This would result in a pressure of 29.92 inches of mercury. You might be asking yourself, what is the purpose of the standard day? Aircraft performance and instrumentation are compared and evaluated in a standard day environment. For an example, we'll use the General Electric CF6-80A2 power plant. It is rated at 50,000 pounds of thrust in a standard day environment. On a hot day, the CF6 may not come close to providing 50,000 pounds of thrust, while on a cold day, the CF6 may be able to provide well over 50,000 pounds of thrust. During a standard day environment, the standard pressure for any altitude is known as pressure altitude. For example, we have already stated the barometric pressure at sea level would be 29.92 inches of mercury. At 1,000 feet, it would be approximately 28.92 inches of mercury. Notice there is 1 inch difference for every 1,000 feet increase in altitude. Now you probably wonder, what is the purpose of pressure altitude? Flight levels are defined using pressure altitude. For example, flight level 180 or pressure altitude of 18,000 feet would have a barometric pressure of 14.94 inches of mercury on a standard day, while flight level 350 or pressure altitude of 35,000 feet would have a barometric pressure of 7.041 inches of mercury. Since we have a good idea of barometric pressures at different altitudes on a standard day, let's compare them to pressures and altitudes on a non-standard day. This is known as density altitude. For example, when the temperature is 95 degrees at sea level, the density altitude is 2,300 feet. That is to say, the barometric pressure at sea level is equivalent to an altitude of 2,300 feet on a standard day. The higher the density altitude, the thinner the air. When the temperature drops to 30 degrees at sea level, the density altitude is equal to approximately 2,000 feet below sea level. Since the density altitude is lower, the air is thicker. The density of the air varies with temperature and pressure. It plays a critical role in flight. For example, when the density altitude is 1,000 feet, an aircraft may need 1,250 feet of runway in order to take off. On a different day with higher temperatures, the density altitude may be up to 4,000 feet. Now the same aircraft needs more runway to take off since the air is thinner.